Okay, so students, this is a typical type of problem that you would find when you're asked to do work with the parabola. Find the vertex, focus, and the directrix. The problem, or not the problem, but the difference in this equation versus the other ones is it's not in any kind of standard form. So we have to take this equation right here and put it into standard form. Now we've already talked about the fact that since it is our y's that are being squared, then the format that we want to find is going to look like this. That should be a y. That looks like an x right there. So that should be y minus k squared is equal to 4p times x minus h. Right, that's the format we want. The issue with this is that we are going to have to do some work to this equation up here, the 1/4 times y squared plus 2y plus 33, in order to even get it to start to look like that. Well, the first thing that we should do here, by the way, this is in really a quasi-general format. It's really not totally general yet. We want to go to standard. Standard is what's written here in blue. General is written up there in black. So we want to convert that. My suggestion to you first is not to distribute that 1/4 across the equation. Do not do that. Rather, divide both sides by 1/4. So when you divide both sides by 1/4, you end up with this. You end up with 4 times x is equal to y squared plus 2y plus 33. That's what you end up with. Y squared plus 2y plus 33 is equal to 4x. Now, since we're solving like this, the y minus k is on the left, so we need everything with a y on one side and everything that doesn't have a y on the other side. So I'm going to first subtract that 33, and that puts everything with a y on one side of the equation and everything that doesn't have a y on the other side. Now, because I'm oriented from reading from left to right, I'm just going to switch this. That's legal in math. Now, some people could say, well, why aren't you changing your signs and stuff like that? Because all I did was just flip it over. That's it. If I flip everything, I don't need to worry about changing any signs at all on there. Okay, so now the issue is going to be how can we get this y squared minus 2y to look like y minus k? How can we do that? Well, we talked about this in a previous class. We do that by something known as completing the square. So I'm going to move this down a little bit. Okay, when I want to complete the square, there were a couple things that we needed to remember. First thing is that there should be a coefficient of 1 in front of the y squared, and there is in this case. If there's not, then we got to do some other factoring, and we'll cover that at another time. All right, so we need to make sure there's a 1 there. The next thing is to take this b coefficient, the 2 in this case, and cut it in half and multiply and square it. So if I take 2 and cut it in half, I get 1, and 1 squared is 1. So what I'm going to have then is this. I'm adding the 1 to both sides of the equation. So once again, what I want to do is I want to make sure that there is a 1 in front of this coefficient right here, or this variable. I want to take the b coefficient and cut that in half. So half of 2 is 1. And then what I want to do is square that number. So if I square 1, I get 1 and add it to both sides. Okay, now what I need to do then is take this expression and factor it. Or you can go through whatever method you learned from way back in Algebra 2 or Algebra 1 or whatever. It doesn't matter as long as you factor it. The reason we're doing this completing the square is that when you do factor it, what you're going to get is y minus some number k becomes y minus some number k. And when you do this, this is y minus k squared. Well, what's that k going to be? Well, again, you can factor it whatever method you want to, but you're going to find out that what's going to happen is it's going to be the y variable and then half of this variable right here. So half of plus 2 is plus 1, and then you just square it. That's what's going to end up. You're going to have half of this y variable, sorry, not half, you're going to have the y variable plus half of the other variable, and then you're just simply going to square it. Let's just get that out of here so it doesn't clutter things. The next thing we're going to look at, now we've got our y minus k part. Now what we have to do is we have to get this expression right here to look like 4p times x minus h. We have to get that to look like 4p times x minus h. Well, the first thing we should do is combine like terms. So if we look at this, I can take 4x, leave it alone, I can take negative 33 plus 1 and get negative 32. So at least I've got that. Now, how do I get my 4p times x minus h? I need to turn this into a situation where I have something times x minus h. So, I notice that I have a 4 in common with both of those, so I'm going to factor a 4 out. So that's going to give me x minus 8. I'll just check my math here on this. Okay, yes, because 4 times x is 4x, 4 times negative x is negative 32. So I have y plus 1 squared is equal to that. Now, if I want to get this into its proper standard form, I'm going to have y plus 1 squared is equal to 4 times 1 times x minus 8. And the reason I want that 1 there is that's going to help me figure out where my other stuff is going to be. Now, we've done a lot of work here, but we haven't solved the problem. We haven't answered the question for the problem yet. We haven't found the vertex and the focus and the directrix and all that good stuff. All we've done is we've come up with our equation. So, I'm going to take this equation right here, and I'm just going to drag it back up towards the top. I'm going to erase a little bit to get some of this clutter out of the way. I'm going to move to a different color. And now we're going to talk about how in the world do we use this equation now, this equation right here, which I am underlining in blue. How do we use that to figure out how to find our vertex, focus, axis of symmetry, all that good stuff we need to do? All right, first thing, you notice that the y is being squared. That means that our axis of symmetry is going to be horizontal. Our axis of symmetry will be horizontal because the y is being squared. If the x were squared, it'd be vertical, but it's going to be horizontal. So that means that our vertex and our focus are going to lie somewhere along this blue line. The next thing we need to realize is that our vertex is the point HK. And H is always tied with the x, K is always tied with the y. So our vertex in this case is going to be the point 8, negative 1. Remember, we always just switch the signs. So if I go to 8, negative 1, the first thing I need to do is put some axes in here. So actually, I'm just going to draw black. Let's see, if I want to go to 8, negative 1, I'm going to make my axis way over here. Now pretend that's a straight one. Oh, that's just terrible. Yeah, that's just horrendous.
Make a new line.
So let's delete that, all right? And let's draw a better looking line here. So we'll make our axis here. I need to go to 8 and then to negative 1. So let's see, 1, 2, 3, 4, 5, 6, 7. Actually, let's drag this over one more. Let's just pull it all the way over here. And if I want to go to negative 1, I'll just go ahead and put this right here. So I'm going to make my x and y axis right there. So my vertex is the point 8, negative 1. So I need to go over 8. 1, 2, 3, 4, 5, 6, 7, 8, and down 1. So my vertex is going to be right there. And I know now that this thing is going to either have to open right or left, and I know my axis of symmetry is going to be along that blue line right there, that blue dotted line. I know that now. Now, because of this being on the axis of symmetry being horizontal, it's either going to open right or left. Since this P number is a positive number, it will open to the right. It will. Now, I don't know how fat or thin it's going to be, but I do know it's going to open to the right. Moreover, I know now that my focus has to be 1 unit in a positive direction away. And since the focus has to be along that blue dotted line, the axis of symmetry, my focus then must be 1 unit away, it must be right there. So my focus is going to be the point 9, -1. Now the only other thing we have to do is the directrix. The directrix is a line that's always perpendicular to the axis of symmetry, and it lies the same distance away from the vertex as the focus does, but in the opposite direction. So if our focus is 1 unit to the right of the vertex, in this case, our directrix is 1 unit to the left. So our directrix will be that red dotted line right there. Now the problem with the directrix is this. If you write your directrix as, let's slide this over a little bit. If you write your directrix as just simply this, it looks like it crosses at, well, 1, 2, 3, 4, 5, 6, 7. If you just write your directrix as that is going to be incorrect, because you have not shown that you understand what a directrix really is. Number one, a directrix is a line, so this needs to be an equation. Number two, it needs to be the correct equation. This is a vertical line, so it's always in the form of x equals our x-intercept. So now we have solved this problem.